This video is education purpose only. My name is Dr. Jagdale, Head Department of Chemistry. Presently I am working as Associate Professor, and today I am going to talk about inorganic chemistry. The main topic name is isomerism and subtopic is stereoisomerism. Student friends, you know that isomers are the compounds having same chemical formulae but different structural arrangements. Their structural arrangements are different either as atoms or groups, or molecules are attached to the central metal atom or ion in different ways, or their space arrangements are different. On the basis of arrangements of atoms, you know that there are two types of isomerisms in coordination compounds. One is known as structural isomerism and second is known as stereoisomerism. In structural isomerism, structural arrangements are different and atoms or groups attached are different in various types of molecules, but their chemical formulas are same. In stereoisomerism, the structural arrangements of groups or atoms in the space are different, and when such types of isomers are formed, these isomers are known as stereoisomers, and the phenomenon is known as stereoisomerism. There are two types of stereoisomerism. One is known as geometrical isomerism, and the second is known as optical isomerism. Okay, first type is geometrical isomerism. Geometrical isomerism is also known as cis or trans isomerisms. And in optical isomerism, there is a formation of dextrorotatory or levorotatory compounds. Actually, here geometrical isomers are known as cis-trans isomers and optical isomers are dextro and levo form of the isomers. Then what is geometrical isomerism? In geometrical isomerism, cis and trans forms are there. You know that cis form means same groups to the same side, same groups to the same side, and trans isomers means here same groups are to the opposite side. Example is, suppose there is a formation of coordination compound, here PT NS3 twice Cl2. There are two forms of these geometrical isomers of this compound PT NS3 twice. This compound is anti-tumor drug and it occurs in two forms. One is known as cis form and second is known as a trans form. In cis form, this is a planar complex. In this planar complex, platinum is at the center position. One chlorine here, second chlorine here, then one NS3 ligand here and second NS3 ligand. This is in square bracket, and this form is known as a cis form. This form is known as cis form. In trans form, this is again a planar structure. In planar structure, platinum is at the center position and same groups are to the opposite side, here NS3 and NS3, and this is a trans form. This form is trans form. What is meant by cis isomer? When same groups are to the same side, that compounds are called as cis isomers or cis compound, and when same groups are to the opposite side, there is a formation of trans 1. And there are two types of stereoisomerisms. One is geometrical isomerism and second is optical isomerism. Geometrical isomerism is called as cis-trans isomerism, and optical isomerism is dextro or Leo forms of isomerism. This is one example for the geometrical isomerism as PT-NH3 twice, and these are the two forms. This form is known as a cis form and this form is known as a trans form. In cis form, same groups are to the same side, and in trans form, same groups are to the opposite side. Second type of isomerism is optical isomerism. In optical isomerism, dextro or Leo forms are considered. You know that what is meant by optical activity. When plane of polarized light is passed through the solution or substance, when it rotates either clockwise direction or anti-clockwise direction, when clockwise direction is there, this direction is known as a positive, and this positive direction is known as dextro-rotatory. It is known as dextro-rotatory. When rotation of plane of polarized light is anti-clockwise direction, it is known as negative rotation and it is called as Leo form. It is called as Leo form. And when there is a rotation of plane of polarized light, then that compound is known as optically active compound, and when two forms are there, they are called as optical isomers, and that phenomenon is known as optical isomerism. Listen again. In optical isomerism, when plane of polarized light is passed and it is either rotated clockwise or anti-clockwise, clockwise rotation is known as a positive rotation called as dextro rotation, and anti-clockwise rotation is called as a negative rotation. It is also known as a Leo rotation. It is known as Leo rotation. In coordination compound, such types of rotations are occur when plane of polarized light is passed through that compound, and they are known as optically active compounds. That isomers are known as optical isomers, and phenomenon is known as optical isomerism. Example is, suppose there is a formation of here chromium complex CrEn3 plus complex ion. This is complex ion. In this complex ion, chromium is at the central metal, and there is a charge on 3 plus. It is called as a central metal ion. 3 bidentate ligand means NH3 ligands are surrounded by central metal ion, and every ligand forms the 2 bonds. Total 6 bonds are formed. Therefore, coordination number of chromium is equal to 6 here. Coordination number is equal to 6. If you draw the structure for chromium, here it is octahedral complex, and in this octahedral complex, here chromium is at the center position. Then there is a formation of 6 bonds. Okay, suppose in the first form, here ethylene diamine, it is a bidentate ligand and it forms the 2 bonds, means 2 coordinate bonds, and you know that this is a chelate compound. Ring structure is formed. Here is ethylene diamine, and you know that ethylene diamine, here is a CH2, then CH2, then NH2, and here is NH2. On nitrogen, there is a lone pair of electron, and that lone pair of electron is donated to the metal, and 2 coordinate bonds are formed, and this is the structure for this ethylene diamine. Listen again. In ethylene diamine, it is a bidentate ligand. Here 2 NH2 groups are there. On nitrogen, there is a lone pair of electron. That lone pair of electron is donated to the metal. This is the central metal ion, and a ring structure is formed there. In CrEn thrice, here this is one group. Then in second one, here is ethylene diamine, and in third, here is ethylene diamine, and it is a bidentate ligand, and 6 coordinate bonds are formed there, and in this complex compound charge is equal to 3 plus. When there is a mirror image of this complex, then this ethylene amine goes to this side, this ethylene amine diamine ligand go to this side, and this ethylene diamine go to this side. Suppose the first one is the dextrorotatory, then second is levorotatory. Means plane of polarized light is passed through this complex compound. Suppose first show the clockwise rotation, it is called as a positive rotation, and when positive rotation is occur there, that complex compound is dextrorotatory. Suppose mirror image is there, then it shows the negative rotation. Negative rotation is anti-clockwise rotation, it is called as a levorotatory, and they show the optical activity. These compounds are optically active compounds. They are known as optical isomers, and that phenomenon is known as optical isomerism. That phenomenon is known as optical isomerism. Next point is, when this compound shows various properties for optical activity, here you know that here dextrorotation means there is a clockwise rotation of plane of polarized light, it is a positive and represented as a small d. It is a positive and represented as small d. In levorotation, there is anti-clockwise rotation, it is called as negative, and this is known as levorotation. When any mixture contains 50% of dextrorotation and 50% of levorotation, that compound or mixture is known as a racemic mixture. It is called as a racemic mixture. In a racemic mixture, the percentage of dextro and levo, that is a D, and L is equal to 50-50%. For optically active compounds, there is a asymmetric atom. That asymmetric atom contains, means that coordination compound contains non-superimposed structures, and two non-superimposed structures are there, and that molecule shows dextro and levorotation. When there is a separation of the D and L, means dextrorotation and levorotation, it is also called as resolution of that compounds. And when D and L, two non-superimposable positions are there, these non-superimposable molecules are known as enantiomorphs, and that phenomenon is known as enantiomorphism. They are what? Enantiomorphs of each other. Then next point is stereoisomerism in coordination number 4 and in coordination number 6. First, in stereoisomerism in coordination number 4. Here stereoisomerism in coordination number is equal to 4. You know that coordination number means number of ligands that are directly attached to the central metal atom or ion. When 4 ligands are directly attached and forms the 4 coordinate bond, then coordination number is equal to 4. Just you have seen the example of here PT, then NS3 twice Cl2. In this complex compound, platinum metal ion is central metal ion, and 4 ligands, out of that 2 are NS3 ligands and 2 are the chloride ligands. These ligands are directly attached to the central metal ion, and therefore coordination number is equal to 4. They show the 2 types of geometries. Number 1 is geometrical isomerism, means 2 types of isomerisms. One is geometrical isomerism and second is known as here optical isomerism. Second is optical isomerism. In geometrical isomerism, when coordination number is equal to 4, there are two types of arrangement. First arrangement is tetrahedral arrangement. And second is known as square planar arrangement. Second is known as square planar arrangement when coordination number is equal to 4. Suppose this is one example as PTNS3 twice Cl2. In a general way, it is represented as metal with A2B2. In general, this complex compound is represented as metal with A2B2. Here M stands for the metal, then A stands for the two ligands, and B stands for the second two ligands of the chloride. Like that, various complex compounds are formed, and they show the tetrahedral and square planar arrangements. You know that tetrahedral arrangement means there is sp3 hybridization. In sp3 hybridization, metal is at the center position and 4 ligands are at the 4 regular corners of the tetrahedron. Here is one ligand, here is a second, here third, and here fourth. And this is the tetrahedral arrangements. In tetrahedral arrangement, all 4 ligands are equivalent. All 4 ligands are equivalent and they are adjacent to each other. No one ligand is opposite to each other, or there is no opposite ligand. Therefore, for tetrahedral arrangement, sp3 hybridization, geometrical isomerism is not possible. Example is, suppose there is metal with 4 ligands, that is Ma4, or suppose if you consider Ma2B2 type of example, no two ligands are opposite to each other, all ligands are equivalent, they are adjacent to each other, therefore cis and trans isomers are not possible in tetrahedral arrangement. Cis and trans isomers are not possible in tetrahedral arrangements. But if you consider the optical isomerism for coordination number is equal to 4, these types of arrangements are possible. Example is, suppose general example is metal A, B, C, D. All ligands are different and this is the complex compound. This is the general representation. Example is, suppose there is a formation of arsenic compound as S, then there is here CS3O, then second is here C2H5, then third one is here OH minus, and fourth one is sulfur. And all these 4 ligands are different. Central metal ion is arsenic and 4 groups are attached, they are ABCD. Then in optical isomerism, if you consider the tetrahedral structure, here arsenic is at the center position, then one ligand is here, second is here, third is here, and fourth is here. Suppose at the top there is a sulfur, then here is OCH3, then here is C2H5, then here is OH, and if you take the mirror image, in mirror image at the center position there is arsenic, then their sulfur remain as it is, that OCH3, here is OCH3, then here C2H5, C2H5, and OH groups go this side, and this is the mirror image of first one, and they first show the clockwise rotation and second shows the anti-clockwise rotation. First show clockwise rotation supposed to be, and second means optical isomerisms are possible in coordination number 4 and in tetrahedral arrangement, but in tetrahedral arrangement, when such types of molecules are formed, all 4 ligands are equivalent, then geometrical isomerisms are not possible, means cis and trans isomers are not possible. Then second one, square planar arrangement when coordination number is equal to 4. This is the example for square planar arrangement. Second example for arrangement is, suppose there is a formation of MA4 type of complex. In MA4 type of complex, when square planar arrangement is there, there is a square. There is square. At the center position, there is a metal, and all ligands are equivalent. All ligands are equivalent. But when such type of molecules are formed, Ma2B2, then cis and trans forms are there. Means in square planar arrangements, geometrical isomerism is possible. And there are various types of examples of geometrical isomerism. In Ma4, that geometrical isomerism is not possible because all 4 groups are similar and they are not opposite to each other. But when there is a formation of Ma2B2, when there is a formation of here Ma2BC type, or there is a formation of here Ma, then there is a B3, in such compound, here geometrical isomerisms are possible. But for square planar complexes, if you consider the optical isomerism, all these complexes are planar in nature and they rarely shows the optical isomerism. They rarely shows the optical isomerism. And this is the first point in stereoisomerism having coordination number is equal to 4. Listen again, in coordination number 4, there is a formation of 4 coordinate bonds and 4 ligands are directly attached to the central metal atom or ion. In stereoisomerism, there are 2 types of isomerisms. One is geometrical isomerism and second is known as optical isomerism. In geometrical isomerism, there is a tetrahedral arrangement. It is sp3 hybridization and there is a tetrahedral shape. And second is square planar arrangement. In that square planar arrangement, there is a dsp2 hybridization and the structure of that molecule is a square planar. Okay, if you consider the tetrahedral arrangement, all groups or atoms or ions attached to the central metal atom or ion like Ma2B2, then like Ma2BC, etc. This is one of the example, and all these groups are equivalent and no single group or atom is opposite to each other. They are adjacent to each other. Therefore, tetrahedral arrangements means isomers are not possible when coordination number is equal to 4 in stereoisomerism as geometrical or cis or trans isomerism. In square planar isomerism, for coordination number 4, here this is the example PTNH3-Cl2. It shows the cis and trans isomers, means geometrical isomers are possible for square planar dsp2 hybridization. If you consider the optical activity for coordination number is equal to 4, you know the optical isomerism means when plane of polarized light is passed through the solution or substance, it either rotate clockwise, that is a positive dextrorotatory, or rotate anticlockwise, it is levorotatory, and this type of complex compound MABCD. All 4 ligands are different with metal or metal ion. This is the example of arsenic compound AsCH3O, C2H5OH and S. When these groups are attached and there is a passing of plane of polarized light, means mirror image is there. Suppose this is the dextrorotatory and this is the levorotatory. Here rotation is clockwise and here rotation is anticlockwise, and when coordination number is equal to 4, there is optical activity for such type of compounds. But if you consider this square planar type of compounds in optical isomerism, all the structures are planar, and when structures are planar, there is a lack or absence of optical activity in coordination number 4 for square planar arrangement. Next point is here optical activity determination for the coordination number is equal to 6, means stereoisomerism, and here coordination number is equal to 6. You know that when 4 ligands are directly attached and they form the 4 coordinate bonds, then that compounds are known as what? Optically active compounds, or they show the stereoisomerisms. Either there is a rotation clockwise or anti-clockwise, or cis or transforms are there. Again, there are 2 types. One is known as geometrical isomerism, and second is known as optical isomerism. Here coordination number is equal to 6. 6 ligands or 6 coordinate bond formation is there. Example is, suppose there is a formation of here CO, then NH3,4 Cl2 2 plus complex ion. This complex compound is octahedral in nature because 6 ligands are directly attached to there. Then there are 2 forms, means one is a cis form and second is a trans form. In cis form, here same groups are to the same side. At the center position there is a cobalt, then one chloride ligand here, second chloride ligand here, then one NH3 is here, then second NH3 is here, then fourth NH3 ligand is here, and this is the structure for cis form having charge 2+. This is cis isomer having coordination number is equal to 6. 6 coordinate bonds are formed and same groups are to the same side, and this is the octahedral structure for CONH3,4Cl2. If you consider the transform, in transform here same groups are to the opposite side. Here is a cobalt, here is Cl, here is Cl, here is NH3, here NH3, then NH3 and NH3, and charge on this complex compound is equal to 2+. Here 2 chloride ligands are opposite to each other. This is the octahedral structure, and in this octahedral structure this form is known as a transform. This form is known as transform, means coordination number is equal to 6. Geometrical isomers are possible. Here example is CONH3,4Cl2 2+. This is the cis form and this is the trans form. If you consider the optical activity, example is, suppose there is a formation of CrEn thrice 3+ complex ion. In this complex ion, there is a formation of a ring structure or heterocyclic ring is formed, and if you consider the heterocyclic ring, you know that at the center position here is a chromium, then ethylene diamine is a bidentate ligand, and suppose here is ethylene diamine, in second here is ethylene diamine, and here third ethylene diamine, and on this complex charge is equal to 3+. When there is a passing of mirror image, here at the center position there is a chromium, then this ligand go to this side, this ligand go to this side, and here this ligand go to opposite side, and this is the what? Opposite image of first one. Here is a mirror. These two are the mirror images of each other. Charge is equal to 3 plus. Suppose this is a dextrorotatory, then this is a levorotatory, and when coordination number is equal to 6, such type of arrangements are possible. In general way, various types of coordination number is equal to 4 and coordination number is equal to 6. Here cis and trans isomers are possible only in case of geometrical isomerism when coordination number is equal to 6. And if you consider the geometrical isomerism is equal to 6, here this is the cis form for this complex ion and this is the trans form. If you consider the optical activity, then suppose this one shows the clockwise, this is the dextrorotatory, then this mirror image shows the anti-clockwise rotation, it is called as lever rotation, and these compounds are the examples of optical activity. Various metal complexes shows the optical activity. One more example is here metal with A, B, C, D, E and F. All 6 ligands are different and they are arranged in various ways. Then they shows the optical activity, and that is the coordination number is equal to 6, and these are the points included in stereoisomerism. Two types of stereoisomerism. One is known as geometrical isomerism and second is optical isomerism. Then stereoisomerism in coordination number 4 and coordination number is equal to 6, and these are the respective examples of stereoisomerism, and I hope that is enough for the stereoisomerism in coordination compound. Thank you.